All right, guys, we're going to be looking at multiplicity, x-intercepts, and building the polynomial. And this is for your flip grid. This is how I want you to demonstrate your flip grid for me today. All right, so the first thing I have is I have chosen randomly my x-intercepts to be 2, 3, and -4. And I've picked an extra point I want the graph to go through, which is 0, -384. I've also randomly assigned their multiplicities. So x-intercept 2 has a multiplicity of 2. The x-intercept of 3 has a multiplicity of 1. X-intercept of -4 has a multiplicity of 3. So the first thing I'm going to do is I'm going to start by giving them their factors, writing out my factors. So x-intercept of 2 would be written with a factor as x minus 2 with a multiplicity of 2, which means that it is squared. I have an x-intercept of 3 with a multiplicity of 1, which means I would just write x minus 3. And then I have an x-intercept of -4 with a multiplicity of 3, which would be x opposite of -4, which is +4 cubed. Now, when I do graph this, I have to remember that the graph at each one of these x-intercepts will be hitting the x-axis with either a u or an n if it is squared, multiplicity 2. It'll go through the x-axis, almost kind of straight through if it is a multiplicity of 1, or if it has a multiplicity of 3, I'll be looking for a swerve that goes through there. So let's get to building this equation so we can check if we've done this right. All right, so the first thing I'm gonna do is I'm gonna set up the polynomial y equals to a, and I'm gonna put my factors in, x minus 2 squared, x minus 3, and x plus 4 cubed. It does not matter the order that I put those in. And then I'm gonna plug in my x and my y. So you're gonna notice that. Let's go ahead and do that. My y value is -384. And then equals to a, and I'm going to plug in 0 minus 2 squared, 0 minus 3, and 0 plus 4 cubed. Now, I'm just going to start simplifying. -384 equals to a, and then 0 minus 2 is -2 squared, which is 4. I've got 0 minus 3, which is -3. And then I've got 0 plus 4, which is 4 cubed. 4 cubed is 64. Now, once I come to this point, I am going to simplify this 4 times 3 times -64. You'll notice that is -768. -768. At this point, let's go ahead and divide that sucker off. So divide by -768. And one thing I know just from Desmos is that my a value will be equal to 0.5. I just pretty much type that into Desmos a little bit. And what I'm gonna do is rewrite the equation. Rewrite equation, okay, with a, okay, which is my vertical stretch. So I'm just gonna simply rewrite y equals to 0.5, x minus 2, x minus 2 squared, x minus 3, and then x plus 4 cubed. All right, so now that I've got that, okay, I'm going to go over here and I'm going to type that in. One thing that I did was I went ahead and put my table, I added a table in, and I put my points of the x-intercepts, and I put a point for the y-intercept. You can see that in the table, and I want to make sure that my graph goes all the way through those. So I'm going to type in my function. Let's call it f of x equals to 0.5. And let's go ahead, go back through here, type it in, x minus 2 squared, x minus 3, and x plus 4 squared. So x minus 2 squared, x minus 3, whoops, and then x plus 4 close parentheses, and I'm going to cube that. Now, let's just revisit that real quick. X minus 2 squared, x minus 3, and x plus 4 cubed. Make sure that's typed in correctly. And it is, and what you'll notice is exactly what I was looking for. It goes through all of the points, okay? And if we reference if we go ahead and reference what we have on our graph, what you can notice real quick is the x minus 2 has the u or the n, the x minus 3 goes straight through, and x plus 4 is kind of swerving through there. Okay, and check what we have there. We have the curving, the swerve through the x minus 4. We have the U shape for a multiplicity of 2 right there, 2. And then we have it going directly through for the multiplicity of 1. All right, hope that helps. There's your demonstration for what I'll be looking for Flipgrid. Remember, there's extra credit if you can convert your factored form equation, demonstrate converting your factored form equation over to standard form. Good luck.